from the Diploma CET 2018 question paper, and for the branch Computer Science and Engineering, and the subject is operating system. In that, the question number 91. The system with multiple CPUs is called. We have four options. The first option is time sharing system, and the second option is desktop system, and the third option is client server system, and the fourth option is parallel system. For the question number 91, the fourth option, that is the parallel system, is the right answer. Why? Because in a single CPU system, only single CPU can take the single task at a time and performs the execution along with the memory. But in multiple CPU system, a multiple CPUs can take the multiple tasks at a time and performs the execution along with the single memory. That memory is called as the shared memory. Okay, in this example, a CPU 1 can take the task 1, the CPU 2 take the task 2. Similarly, the CPU 3 take the task 3 at a time, and these tasks are executed at a time, okay, by using the single memory. So here task 1, task 2 and task 3 are executed parallelly. So a system with a multiple CPUs is called as the parallel system. That is option number 4 from the Diploma CET 2018 question paper, and for the branch Computer Science and Engineering, and the subject is operating system. Okay, in that the question number 92. Which one of the following is a synchronization tool? For question number 92, we have four options. The first option is thread, the second option is pipe, the third option is semaphore, and the fourth option is socket. For question number 92, the option number 3, that is semaphore, is the right answer. Move on to question number 96. The code that changes the value of the semaphore is. We have four options. In that, the first option is remainder section code, the second option is non-critical section code, and the third option is entry section code, and the fourth option is critical section code. For question number 96, the option number 4, that is critical section code, is the right answer. Then what is meant by semaphore? A semaphore is usually a variable, and this variable is used to solve the critical section problem, and this semaphore is also called as the synchronization tool. Why? Because by using the semaphore we can achieve the process synchronization. Okay, then in semaphore we have two operations, that is wait operation and the signal operation. In wait operation, if the semaphore is equal to 0, then no process will enter into the critical section. Similarly, if the semaphore value is other than 0, that means if the semaphore value is equal to 1, then the semaphore value is decremented by 1 in wait operation. Similarly, the other operation is signal operation. In signal operation, the semaphore value is simply incremented by 1. Okay, in this example, we are taking process P1 and P2. Okay, and both these processes are initialized by the semaphore value is equal to 1. Here we are considering the process P1 is entering into the wait operation. Okay, here the wait operation checks the semaphore value. If the semaphore value is equal to 0, then the process P1 will not enter into the critical section. But the process P1 is initialized with the semaphore value 1. So it will easily enter into the critical section. Okay, and the semaphore value becomes to 0. Before, the semaphore value is equal to 1. Now the semaphore value is equal to 0. Okay, and if suppose the process P2 wants to go to the critical section, then the wait operation will prevent it. Why? Because now the semaphore value is equal to 0. So the process P2 will not go into the critical section. Okay, after executing the critical section code by the process P1, then it will enter into the signal operation. In signal operation, the semaphore value is simply incremented by 1. Before, the semaphore value is equal to 0. Now the semaphore value becomes 1. Okay, so it will change the semaphore value. Before it is 1, during critical section code the semaphore value is equal to 0. After that, again the semaphore value is equal to 1. Okay, similarly, the process P2 now will enter into the critical section code. Why? Because now the semaphore value becomes 1. So it will easily enter into the critical section code, and then here the semaphore value is again decremented by 0. After that, after executing all the critical section code, then it will enter into the signal operation. Here the semaphore value is incremented by 1. So the semaphore value now becomes 1. So for question number 92, that is, which one of the following is the synchronization tool? That is the semaphore. That is option number 3. Similarly, for question number 96, the code that changes the value of the semaphore is, that is the option number 4. Critical section code is the right answer. From the Diploma CET 2018 question paper, and for the branch Computer Science and Engineering, and the subject is operating system. In that, the question number 93. Which one of the following is the address generated by the CPU? For that question, we have 4 options. In that, the first option is physical address, the second option is absolute address, the third option is logical address, and the fourth option is virtual address. For the question number 93, the option number 3, that is logical address, is the right answer. Why? Because in CPU, the CPU always generates a logical address, and this logical address is converted into physical address by the MMU. Okay, the MMU represents memory management unit. This is the hardware device. This hardware device adds logical address along with the base address. In this example, we are taking 340 as the logical address and 2000 as the base address. So the MMU adds 2000 and 340. So the result becomes 2340. This is the physical address, and this physical address always points to the physical memory, so that whatever the data present in 2340 location, that data must be fetched or it can be stored depending on the program we written. So for question number 93, the option number 3, that is logical address, is the right answer. From the Diploma CET 2018 question paper, and for the branch Computer Science and Engineering, and the subject is operating system. In that, the question number 94. The virtual memory is normally implemented by, we have 4 options. In that, the first option is demand paging, the second option is buses, and the third option is virtualization, and the fourth option is segmentation. For the question number 94, the option number 1, that is demand paging, is the right answer. Move on to question number 99. The page fault occurs when, we have 4 options. In that, the first option is the page is corrupted by the application software. The second option, the page is in the main memory. The third option is the page is not in the main memory. And the fourth option is one tries to divide a number by 0. For question number 99, the third option, that is the page is not in the main memory, is the right answer. Then, what is meant by virtual memory? A virtual memory, it is the space present in the hard disk or the secondary memory, or it can also be defined as it is the portion of the secondary memory or the hard disk. Suppose we have a computer program of 50 GB and the main memory of 8 GB. Then during program execution, the entire program of 50 GB is not loaded into the main memory, and it is impossible also. So what happens is, a program of 50 GB is stored in the virtual memory in the form of pages, so that only required portions or the required pages or the required programs is only loaded into the main memory. This is the concept of virtual memory. Okay, then what is meant by demand paging? A demand paging, it is the process of loading the pages into the main memory on a demand, is called as the demand paging. Okay, that means here the pages which is loaded from the virtual memory into the main memory, okay, on a demand, is called as the demand paging. Here demand represents whenever a page fault occurs. Then what is meant by page fault? A page fault, it occurs whenever a page is not in the main memory. That means here the page fault occurs whenever a program is not present in the main memory in the form of pages. So the fault notifies the operating system that the program must load into the main memory in the form of pages from the virtual memory. Okay, this is the concept of page fault. So question number 94, the virtual memory is normally implemented by the first option, that is demand paging is the right answer. Similarly, a page fault occurs, okay, it occurs when the third option, the page is not in the main memory, is the right answer. Right answer. So for question number 99, the option number 3 is the right answer. From the Diploma CET 2018 question paper and for the branch Computer Science and Engineering, and the subject is operating system. In that, the question number 95. In segmentation, each address is specified by. For question number 95, we have 4 options. In that, the first option is a segment number and offset, and the second option is an offset and a value, and the third option is a value and a segment number, and the fourth option is a key and a value. For question number 95, the option number 1, that is a segment number and offset, is the right answer. What is meant by segmentation? In operating system, a segmentation is the memory management technique in which the memory is divided into variable sized parts and each part is known as the segment. Suppose consider a program. In program, we have different logical units such as subroutines, main functions, procedure, library functions, and stack. And these logical units are acted as the segments, and these are all stored in the logical address space. Okay. Here, the subroutine logical unit is represented as segment 0 and main function is represented as segment 1 and the procedure is represented as segment 2 and the library function is represented as segment 4 and the stack is represented as segment 3. Okay, here we are having the segment table. The segment table maps a logical address into the physical memory by using the segment number and the offset value. Okay, here the segment name, that is segment 0, segment 1, segment 2, segment 3 and the segment 4. Okay, these are the name of the segments. And the segment number, it is the starting address of the segment. Here for segment 0, we are having the starting address is 1400. That is 1400 in the physical memory. Okay. And the offset value is 1000. Here the offset value represents the size of the segment. Here for segment 0, its size is 1000 and its starting address is 1400. So the segment 0 is started from 1400 and it ends at 2400 because its length is 1000. So a segment 0 is represented between 1400 to 2400. Similarly, for segment 1, its segment number is 6300. It is the starting address. Okay, and it is end at 6700. So its ranges from 6300 to 6700. Similarly for segment 2, okay, its segment number is 4300 and this is the initial or starting address for the segment 2 and its range is 400. Okay, so it ranges from 4300 to 4700. Similarly for segment 3, its starting address is 3200. Okay, and its length is 1100. So when you add for 3200 and 1100, it becomes 4300. So its range lies between 3200 to 4300. Similarly for segment 4, its segment number is 4700. So for segment 4, its starting address is 4700 and its offset value is the length of the segment 4. It is 1000. So when you add for 4700 to 1000, then it becomes 5700. So it ranges between 4700 to 5700. So for question number 95, the option number 1, that is a segment number and a offset, is the right answer.